Good day, everyone. You're welcome to.
Good day, everyone.
Good day, everyone. You're welcome to Tacsfon Lautech Academy. In today's physics class, I will be taking you dynamics. So briefly, dynamics is just the study of motion and the force causing it, and it was started by Galileo. Then Newton took over after the death of Galileo Galilei. So basically, let's treat the Newton's laws of motion. So the first law of motion states that Newton's first law of motion states that everybody continues in its state of rest or uniform motion in a straight line unless it is acted upon by a net force. That means anybody, like a body, or let's use a ball for example, a moving ball would keep moving only if it is acted upon by an external force. That's when the position will change. So let's talk about the third law before the second law. The third law states that action and reaction are always equal but opposite. When the force is tending to pull something, there's also another force tending to drag it back. So they are always equal, but now their direction is negating each other, they are opposite. So straight up to the second law. The change of momentum per unit time is proportional to the impressed force and takes place in the direction of the force. Let me briefly explain that. He said the change of momentum per unit time. Momentum is mass times velocity, the mass times velocity of the body. So they said the change of momentum per unit time is proportional to the impressed force. So the force is directly proportional to the change in momentum. That means the final momentum minus the initial momentum with respect to time, per unit time. So F, the force F is equals to M into bracket V minus U. So making this, and we know our acceleration is equals to velocity over time. We know our acceleration is equals to velocity over time. So definitely this will make it F equals ma. So that's how the force is gotten. F is equals to ma. So I would like us to solve a question under the second law application. Alright, this question states, calculate the force acting on a body of mass 5 kg that will produce a velocity of 10 meters per second in a time of 5 seconds. So firstly, you just know, okay, you are calculating the force F, and that is equals to F is equals to ma, the mass times the acceleration. So now looking at our question, you can list what you were given. Your mass is equals to 5 kg. We are given the velocity, which is equals to 10 meters per second, and we are given the time t, which is equals to 5 seconds. So you have to calculate the force now. We have the mass, but we don't have the acceleration. So how do we get acceleration? Just recall, acceleration is equal to velocity over time taken. So that's 10 over 5. So that's 2 meters per second squared. So after getting that, straight up you get your force by imputing the value of the mass and the acceleration gotten. The mass is 5 multiplied by the acceleration, that's 2. So the force is equals to 10. Now the unit for force is Newton. Now let's move to the next section. So briefly let me explain centripetal and centrifugal force. Centripetal force, this is the force required to keep an object of mass m in a circular path. That means when you are having an object moving in a circular path continuously, the force keeping it to keep moving in that circular path is called centripetal force, and the force is given as half mv square over r, where the m is the mass of the object, the v is the velocity at which the object is moving, the r is the radius at which the object is making to the center of this circular path. So centrifugal is just the opposite of the centripetal. It's the force tending to pull the object to the center. Is the force tending to pull the object to the center, while centripetal is the force tending to is the force required to keep it in the circular path. Centrifugal is tending it to pull it to the center. Do you get that? So to get this centripetal force, you will be given your mass, you will multiply it with the square of the velocity, and you divide it by the radius. You all get that? Alright. So let's talk about Newton's law of universal gravitation. This is also a simple law. The law states that the gravitational force of attraction acting between any two bodies of mass m1 and m2 is proportional to the product of the two masses and inversely proportional to the square of the distance r between them. Let's say probably we're having a mass here and a mass here. Just stating that the force of attraction between them is the product of this mass m1 mass m2 and inversely proportional. The force is directly proportional to the product and inversely proportional as the square of the distance r between them. So that's also what this law is talking about. So this is the formula. So firstly, it will be given as f is directly proportional to m1 m2, then inversely proportional with the distance r squared. Immediately we remove this proportionality sign. This proportionality constant would come in g. So that g is given as a constant 6.67 times 10 raised to power minus 11 Newton meter squared per kilogram square. So let's take this example. Calculate the force of attraction of two cars. So let's solve that here. Alright, so let's solve this. Calculate the force of attraction of two cars 5 meters apart. So what to do from there? The distance between them is 5 meters. We note that first. Calculate the force of attraction of two cars 5 meters apart. If the masses of the cars are 100 kg and 1000 kg and 1200 kg, the first mass m1 1000 kg, the second mass m2 1200 kg. So straight up inserting it into this formula, we get the force is equals to m1 m2 over r squared. So our g is 6.67 times 10 raised to power minus 11 multiplied by the first mass, that's 1000 kg multiplied by 1200 kg divided by the square of the distance between them. So the answer now would be 3.2. When you punch your calculator, you get 3.2 times 10 raised to power minus 6 Newton. The unit of force is always Newton. You get that? So impulse and momentum. The momentum P of a body is the product of mass m of the body and its velocity. The momentum P of a body is the product of mass m of the body and its velocity. So what I was just trying to say, the momentum P is equal to the product of the mass and the velocity of the body. That one is simple. So impulse now, straight to impulse. Impulse is the product of the force and the time. So impulse is the product of the force and time. This is force and time. Force and time, and its time during which it acts, provided the force is constant. So this is the impulse. Definitely, you can equate these formulas together. If you ask to calculate the impulse, either you multiply the force and the time, or if these parameters are given, that is the impulse. So now straight, let's move to law of conservation of momentum. So law of conservation of momentum, briefly, is talking about the product of the mass and velocity of objects that collide. When you're having two objects, one, object two, if the two objects collide together, the summation of the individual momentum is equal to the summation of their final momentum after collision. You understand that? That's why you're having this is the momentum for the first body. Let's call this body A. This is momentum for body A. This is momentum for body B before collision. So immediately after collision, the summation of the individual momentum after collision must be equal to the summation of the individual momentum before collision. So let's take this example. A 5 kilogram mass moving in the positive x direction. A 5, let's call this is the mass now. 5 kilogram moving in the positive x direction. This is the positive x direction at 30 meters per second. Collides head on with another body. Head on. What they mean by this head on is that another body comes together, their head collides. Do you get that? Their head collides. So from here this is the direction they are coming together, they are negating each other. And we were told that this one is 2 kg at 50 meters per second in the direction. If the bodies stick together after collision, find the velocity after collision. This is very simple. They said if the bodies stick together after collision, what they meant by if the body sticks together after collision is that if the body sticks together after collision, they will move with the same velocity. But if they don't stick together, they will move with separate velocity. So we can reframe our formula due to this question by saying let's call this A, let's call this B. So MA UA plus MB UB is equal to MAVA plus MBVB. But we were told that they collide together, they stick together after collision. Definitely that will be the velocities will be the same there. So having MA plus MB multiplied by V, velocities will be the same. So we are told to calculate the velocity after collision. This is the V. So our mass and acceleration, that velocity, initial velocity, that's 5 multiplied by 30 plus 50 multiplied by 2. But because this one is coming in the opposite direction, since it is coming in the opposite direction, it will negate it. So it will carry a negative sign. Causing it to show that it is negating it. Equals to 5 plus 2 multiplied by 7. Do you understand that? Do you get that? So 5 times 30 now, that's 150. So 50 times 2, that's 100, is equals to 5 plus 2, that's 7. So you are having 150 minus, that's 50, equals to 7. Then V is equals to 50 over 7. Do you all get that? So from here, v is equals to 50 over 7. Then 50 over 7 is equal to 7.1. 7.1. Do you all get that? So that's 7.14 meter. Alright, let me write it here clearly for you to see. So the velocity is equal to 7.14 meter per seconds. Do we get that? So it is because they said they stick together after collision. That was why the same velocity is applied immediately after collision. You all get that? So with that, we are done with today's lecture under dynamics. Thank you very much.